Well, hello again. Today's notes are on complex numbers. This is section 2-4 in your book. And we got to get into what complex numbers are to start. And first of all, complex numbers are based on imaginary numbers. Now, the imaginary number is symbolized with the letter I. Now, what I is equal to is the square root of -1. Many people don't like imaginary numbers because they can't visualize what this is. Well, imaginary numbers were developed by mathematicians years ago basically to do mathematics that they couldn't do without it. And then with the inclusion of imaginary numbers, there's so much more that we can do mathematically. So the imaginary number is the square root of -1, a number that does not exist. If we square both sides of that, we get I squared equals -1, so just another way of writing that. Now what a complex number is any real part plus or minus any imaginary part. So for example, the number 5 plus 3i is a complex number. In fact, the number 7 is a complex number. It's like 7 plus 0i. In fact, the number 2i is a complex number. It's like 0 plus 2i. So all these are complex numbers. Any real part plus or minus any imaginary part. Now, complex conjugate is, hey, you take that complex number and we write it with the opposite sign in front of the imaginary part. So 5 plus 3i and 5 minus 3i are complex conjugates. Okay, now that we've got that out of the way, let's jump into examples. So we've got these two these two complex numbers. We need to add them, multiply them. Add, subtract them, multiply, and divide. Okay, so if we were to add these, I'm just going to write this out. 5 plus 3i plus 2 minus 7i. Actually, adding complex numbers is a piece of cake because it's really just combining like terms. So that gives us 7 for our real part. It gives us minus 4i for the imaginary part, and we're done. If we are to subtract these, now to subtract, I'm going to put these in parentheses because we just have to be careful here when we subtract that we're distributing that minus sign. But if we subtract these, being real careful with those positive and negative signs, 5 minus 2 is 3. 3i minus a minus 7i is plus 10i. And there's what you get when you subtract these. Okay, let's do something a little more difficult. Let's multiply. So that gives us 5 plus 3i times 2 minus 7i. Now, even multiplying these isn't bad because it's really just a distributive property. So let's try that out. So 5 times 2 is 10. 5 times minus 7i is minus 35i. 3i times 2 is plus 6i. And 3i times minus 7i is minus 21i squared. Hey, keep in mind, I squared is -1, so this is like plus 21. Now we can combine some like terms. If we do that, we get 31 minus 29i. And just so you know, the directions said write answers in standard form. This is standard form. Real number part plus or minus imaginary part. Okay, last thing we want to do is divide these two. Now dividing complex numbers is pretty difficult. I was going to say pretty complex, but that'd be bad. So dividing complex numbers is pretty complex. And we can write this out just fine, but this is not in standard form. To get it in standard form, we have to do some algebra here. And what we need to do is multiply top and bottom by something to make it look like this answer in the end. And the something we want to multiply by is the conjugate of the denominator. Whatever your denominator is, multiply top and bottom by that conjugate. Okay, now we can multiply these using the distributive property. So if we do that, we get on the bottom here, we get 4, we get minus 14i plus 14i. That's why we do it, because those I terms will cancel out. They'll eliminate themselves. They're equal to 0. Minus 14i plus 14i. Then we get minus 49i squared. On top, we get 5 times 2 is 10. Then we get plus 6i plus 35i. Those I terms will not be eliminated on top. and then plus 21I squared. Now remembering that I squared equals -1, this is going to be 4 plus 49. This is 53. I squared is -1, so this is like minus 21. So this is going to be minus 11 plus 41I. Now, standard form means a whole or real number part plus imaginary part. So I'm just going to break this down. -11 over 53 plus 41 over 53 times I. So I think you'll all agree, adding these, subtracting these, pretty easy. Multiplying is a little tougher. Dividing is definitely the toughest of these operations. Okay, let's move on. Second example, we need to multiply these. Now, what I'm going to do first, do not write this down. I'm going to do this incorrectly. Well, incorrectly, we would say, hey, let's just make this the square root of everything. Multiply these two together. Simplify what we can. And write this as 2 times the square root of 3. This is actually the wrong answer. Here's how we should have done this. We should try to simplify these square roots first, okay? Square root of -6 is like -1 times 6. Square root of -2 is -1 times 2. Now, we know I is equal to the square root of -1, so I'm going to write this as I times the square root of 6, and also I times the square root of 2. So if we multiply what we have now, I times I is I squared. Square root of 6 times square root of 2 is square root of 12. We can simplify that square root of 12 as 2 times the square root of 3. We can simplify I squared as -1, so we end up with this answer here. So we're not going to see a ton of these kind of problems, but just be careful. If you have some square roots with a negative in there, take care of that I first, okay? Then we can simplify things. You notice the final answer we got was not much different from what we had before, but it is different, so we have to be careful. All right, next problem. Directions say solve using the quadratic formula. Now, even if it didn't say using the quadratic formula, let's think about how we could solve this. We could solve this by trying to factor. But if you try that, you'll notice that, hey, factoring this is not possible. We just can't do it. So I'm going to get rid of this here. And there are certain problems, we've seen them in the past, where factoring just doesn't work. Factoring is convenient when it works, but sometimes it doesn't work. So when factoring does not work, we have to rely on other methods. One of those methods is called using the quadratic formula. Now I know you learned the quadratic formula in your Algebra 2 days, but you may not have remembered the quadratic formula. So I'm going to give you a method that's going to help you always remember this forever and ever. And it is to sing a song with this. So please sing along with me as I present the quadratic formula. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. Yes, thank you, thank you, thank you very much. So what a stands for is this first coefficient, b is this second one, c is this third one. And if we plug those numbers into this formula, it'll tell us the two zeros, the two solutions. We have found zeros in the past by factoring. This one just didn't work out. Quadratic formula will always work for you if you have a quadratic equation. So let's plug in what we know. So b is -5, so I'm going to say -5, one negative from the formula, one from the problem, so that's just 5, plus or minus the square root of b squared, so 5 squared is 25, minus 4 times 2 times 7, all over 2 times 2. Let's simplify a little further. 5 minus square root of, let's see here, 4 times 2 is 8, times 7, that's 25 minus 56, all over 4. We'll bring our work up here. That's going to be 5 plus or minus the square root of, let's see here, 25 minus 56, I believe is -31, all over 4. And -31, we don't like those negatives in that square root sign, so that's where we can factor out a -1. We can say I times the square root of 31 over 4. Now, since we don't know the square root of 31, we can't really go any further here. So these are our two solutions. You might say, what do you mean two solutions? One is 5 plus I root 31 all over 4. One of them is 5 minus I root 31 all over 4. So there's our two solutions to this equation. If you plug that number in place of x, you will get an answer of 0. All right, let's try one more like that. Now, no need to sing it along because we already know this. We haven't memorized forever now that we've heard that song. But if you hum along, that's okay. Okay, so we know A is 1, we know B is -4, we know C is 5. I'm going to plug in what we know. We'll go relatively quickly here. And once you're good at this, you can take some shortcuts here and there. Okay, let's look at that square root. Square root of 4 would be 2. Square root of -4 is 2i. So this whole thing is going to be 4 plus or minus 2i over 2. Which if we divide everything by 2, careful, don't just cross off the 2's. We need to divide everything on top by 2. So I can write this as 2 plus or minus I all over 1 now. So there's our two solutions, 2 plus I and 2 minus I. So once you're good at the quadratic formula, it's really a relatively quick and easy way to find solutions to quadratic equations. Okay, so now we know a little bit about complex numbers, these imaginary numbers. This is going to be combined with what we knew before in our next set of notes, but for now, we've got an assignment to look at to practice a little bit. So check this out. When you're done, move on to 2-5.